So we're now into the 11th lesson of our quadratic unit, graphing from factored form. And our warm-up question is to find some of these key features. So to just label this again, this is our x-intercept. I'm just going to put x-int. This is another x-intercept. And then down here, this is going to be a y-intercept. So these are listed as points. We're going to solve for the x-intercepts first directly using right here our factored form. So from factored form, what you do is you set w of x equal to 0. So we would say 0 equals x plus 1.6 times x minus 2. And then what you do, if you know, using the zero product property, if two factors multiply to be 0, you can set both the factors equal to 0. One of them has to be 0. So what we're going to do is set both factors equal to 0. So you would say x plus 1.6 equals 0 and x minus 2 equals 0. So then we need to solve both equations. So when we have the x plus 1.6, the opposite of adding 1.6 is just subtracting 1.6. Remember to do that on both sides. So this is going to make 0 or cancel out. So we're going to get x equals, and 0 minus 1.6 is negative 1.6. Now in looking at this 0, this means right here that x is equal to negative 1.6. But if I'm looking at this x-intercept, they want it as a point. So if we did the point for a and b, we know that x is equal to negative 1.6. And then the y-coordinate, this is along the line y equals 0. So we would also have 0 there. So now we have to figure out, to get c and d, we have to solve for the other x-intercept. So the opposite here of x minus 2 is 0 is adding 2. So I add 2 to both sides. And 0 plus 2 is 2. So x equals 2. So if x equals 2, we then have to find the y-coordinate. So we would get 2 and then 0. And now to find the y-intercept. If you remember from previous lessons, for the y-intercept, we need standard form. So what we're going to have to do is take our factored form of the function w of x equals x plus 1.6 times x minus 2. And we're going to have to multiply that out. So in order to multiply that out, I'm going to go x times x, which gives me x squared. And then x times negative 2. So that would be minus 2x. And then on the inside, 1.6 times x. So plus 1.6x. And then 1.6 times negative 2. Positive times a negative is going to be a negative. And 1.6 times 2 is going to be 3.2. Now, I can combine like terms, but I don't really need to in order to answer the question, because I know that this number over here at the end, the number by itself, is my y-intercept. So my y-intercept, we would just say y equals negative 3.2. Or to list that as a point, the y-axis is along the line x equals 0. So we would put in 0 for x and then negative 3.2 for y. So now what we're going to do is complete a table of values for each functions, then determine the x-intercept and the vertex from each graph. Be prepared to explain how you know. So we're going to start with this graph on the left, and we see that the function is f of x equals x times, in parentheses, x plus 4. So our input is x, and then we output x, and then we add x plus 4, and then multiply it by x. So in substituting, we take negative 4 on the outside of the parentheses. And on the inside, before I multiply, I need to go negative 4 plus 4. Well, I'm going to simplify that before I actually do the calculation. And I know that negative 4 plus 4 is going to make 0. So in multiplying negative 4 times 0, anything times 0 is going to make 0. And then we're going to substitute in negative 3. So if I put negative 3 in for x, we have negative 3 parentheses, and then negative 3 plus 4. Well, that's the same as 4 minus 3, which is 1. And then I just multiply. Negative 3 times 1 is negative 3. Negative 2 and negative 1 have been done. So we just need to substitute in 0. So then 0 times 0 plus 4 is 4. So 0 times 4 is 0. And then if we substitute in 1, 1 times 1 plus 4 is 5. So 1 times 5 is 5. And then plugging in 2, 2 times 6 is 12. And plugging in 3, 3 times 7 is 21. And then lastly with 5, 5 times, and then 5 plus 4 is 9. And 5 times 9 is 45. So to solve for the X-intercepts, we can actually do that directly. We've learned how to do that. So we just take our two factors and say, we're going to set both things equal to 0. So our first factor is x. So we have x is equal to 0. I have one factor. We know that my X-intercept, we know my first 0 is x is going to be 0. Or to list that as a point, 0 for x and 0 for y. And then our next 0 that we're going to find is x plus 4 equals 0. So in solving that equation, I say I need to undo the adding a 4. So I subtract 4 from both sides. And I get x is equal to negative 4. So my other one, we have x equals negative 4. And we know that the y coordinate is 0 if I list that as a point. So it would be negative 4 for x and 0 for y. The vertex we're actually going to look for on the graph. So we're going to graph this point, or these points. So if x is negative 5, that's over here, I need to go up and have f of x be 5. So this is 10. This has to be 5. So I go up to this value right here, and I put my dot. So I'd like to put a little check mark along the lines that I've graphed. So if x is negative 4, we go up to 0. So negative 4 and then 0 is right here. And then if x is negative 3, we go to negative 3. If x is negative 2, we go to negative 4. Again, you just kind of have to estimate right there. If x is negative 1, you go to negative 3. And then if x is 0, y is 0. And then if x is 1, y is 5. So 1 and then 5. If x is 2, so here's 2. I'm going to estimate that 12 is about right there. If x is 3, y is 21. So over 1, 2, 3, and then up 21 brings me about right here. And then if x is 4, y is 32. And then if x is 5, y is 45. And we can just connect our lines to make a parabola. And again, we could see that if this goes off too, we know that parabolas are going to be symmetrical. So it's going to kind of draw that. In looking at our key features, we have our x-intercepts here and here. And then this point right here is my vertex. And this parabola, that's a minimum point. But my vertex is at -2 for x. So if I look, it's at this point, -2 for x and -4 for y. But I do want to talk about how to find that from the table. So if you notice, the y values are symmetrical around the vertex. So do you see how -3 and -3 are linked, and 0 and 0 are linked, and 5 and 5 are linked? That middle is how you see the vertex. So what I want for you to do now is substitute your values into that equation, find the x-intercepts, find the vertex. Yeah. So now, ladies and gentlemen, if we substitute our points in and then graph, we notice right here that this bottom point, pardon my graph right here, but that's my vertex. So the vertex is at 1, 2, and then if I look up here at 2, you're at -4. So I'm going to label that. That's 2, -4. Now my x-intercepts are 4 and 0. So 4, we could say x is 4, y is 0 to list it as a point. And then here, if x equals 0, we can list that as 0, 0. We could also plug those in directly. Again, we know that 0 is going to be the y coordinate, or the y value for the x-axis. So if we set 0 equal to, I'm sorry, made a mistake there, but 0 equals to x times x minus 4. Using the zero product property, we just set both factors equal to 0. So x equals 0, and we have one solution there. And then x minus 4 equals 0. We have to solve by adding 4 to both sides, and we get x equals 4. So we got both of those, and then we can list them as a point. Moving on now to figure out more of how we can find the vertex, and we're going to examine the vertex in factored form. So here's what we're going to do. So in looking at that, to find our x-intercepts, we're just going to solve, and I'm going to put my equations over here. So we have x plus 3 equals 0, and then to solve that, on doing plus 3, I would subtract 3 from both sides. And then 0 minus 3, well, that's just -3. So my x-intercepts are x equals -3, and I'll list them as a 0. And then here we have x minus 5 equals 0. And then add 5. And sorry, that's a little small, but x equals 5. Now to go back and figure out, well, how do we figure out the x-coordinate of the vertex? Let's go back and look at the x-intercepts on the graph and see where the vertex is. So here are my two x-intercepts for this parabola. And I notice that the vertex is right in the middle. Same thing over here. We have our x-intercepts and the vertex is right in the middle. Well, to find the middle of these x-intercepts, what we would do is just average the x-intercepts, and we'll just put xi and t. So if I want to do that, to find the average, I'd go -3 plus 5, and then divide that by 2. We're going to use the division bar, so -3 plus 5, and then divide it by 2. If I had to calculate -3 plus 5, that turns into 2 over 2, which just gives us 1. So if we know that the x-coordinate of the vertex is 1, we could substitute back into the function to get the y-coordinate, and we'll do that more later. So now we're going to solve for my x-intercepts over here. So I'm going to put that work over here and say, well, 2x equals 0, and x minus 3 equals 0. So divide both sides by 2, and we see x equals 0. And then solving this simple equation, add 3 to both sides, and then we get x equals 3. Now to find the x-coordinate of the vertex, we find the average. So we do 0 plus 3 over 2. 0 plus 3 is 3, and then over 2. We could leave that improper fraction and say x is 3 over 2, or if you're a decimal person, that's 1.5. So now I'm going to leave you to finish out the rest and the assignment on the back.